In this video, we'll discuss softmax prediction in PyTorch. So the directed graph for softmax regression is identical to that of multiple output linear regression, but as we discussed before, there is an actual nonlinearity applied in the training, but for prediction, it doesn't really matter. So the model is identical to multiple output linear regression, but instead of y, we use z, and we're very interested in the column indexes of z. And the same thing will apply to multiple samples. Now let's talk about custom modules. So we have our softmax class or custom module, and when we create the object, we'll vary the parameter outSize. This will correspond to the number of classes. So we use our softmax constructor, and we have 2 inputs and 3 outputs corresponding to 3 classes. So we'll use our color model to illustrate what's going on. So we have an input tensor of 2 dimensions. We input it to our model, and we get our output z. Now let's bring the columns a little closer to get a better idea of what's going on. So we call the function max on z, and the argument 1 indicates it would like the maximum with respect to the axis 1, or the maximum with respect to each column. And the output nothing is the actual value of the maximum value, and as we're not interested in that, we'll leave it as a blank in Python. So the maximum value of z is 10, and it corresponds to column index 1. Therefore, the output tensor is 1. Same things applies to multiple inputs. So we'll use our model to represent the actual outputs. We'll input to our model, and we'll get the value of z, and we'll call the max function again. And this time, it'll find the maximum index value with respect to the columns for each row. So for the first 2 samples, the maximum index corresponds to column 1. And for the second 2 samples, the maximum index corresponds to column 2. And that's it.